Hello, let's see another example on design of steel connections. This is third example on the design of bolted connection. Two examples already we have discussed in detail. This is third example. So in this, design suitable bolted connection for a single angle strut made up of ISA 100 into 100 into 10 mm using 12 mm gusset plate for a factored compressive load of 175 kN. Assume 20 mm bolts of grade 4.6. Draw connection details. Okay, this is a statement of this particular numerically. One plate which is having Indian standard angle, ISA Indian standard angle is given, which is equal angle section 100 by 100 by 10 mm, and this angle section is connected with 12 mm thick gusset plate, okay, and which carries compressive load of 175 kilonewton. Okay, bolt diameter is given 20 mm, and we have to draw these connections. Let's see given data first. ISA 100 into 100 into 10 mm is given, 12 mm gusset plate is given, that is thickness of gusset plate is given, and then factor load which carries by that gusset plate is given. 20 mm diameter bolt is provided to us. Then assume FE 410 grade of angle हा 4.6 बोल्टवरून आपण डायरेक्टली अज्यूम करतो, तो घेतो अकॉर्डिंग टू IS specifications, and that is FY. FE means we take it as FY 410 MPa or Newton per mm square, same meaning. For bolts of grade 4.6, FUB is 400 MPa or Newton per mm square, FUB and FY. We have already used these terms in previous two examples. Okay. For 20 mm bolt, A and B 245 mm square. Now it is again directly taken. You can calculate A and B is equal to pi by 4 and D square. D is 20. You can calculate. You will get same answer of A and B. A and B is equal to pi by 4 D square. Use D 20 and find out A and B. Okay. Diameter of hole DN or D naught is 22 mm because we add additional 2 in the 20 for hole diameter. Okay, 20 plus 2, that becomes 22 mm. Then gamma MB or gamma M naught is partial safety factor for bolt and angle, that we usually take as 1.25. Then first step we have to follow is to find shear strength of bolt. Okay, this is formula for design shear strength of bolt, VDSB, that is VNSB upon gamma M naught. Okay, here VDSB is directly found out, and that's why VNSB upon gamma M naught is directly taken into the formula. usually we find out VNSB first. Okay, and formula of VNSB that we have already studied in previous two examples. VNSB is equal to FUB upon square root 3. Instead of square root sign, they have mentioned SQRT. FUB upon square root of 3 into NN into ANB plus NS into ASB, whole divided by gamma MB, that is 1.25. We are finding VDSB directly, that's why that divided by gamma MB is there. FUB 400 upon square root 3 into 1 into 245 A and B. NN is again 1 here, and A and B becomes 245. Then again ENS is 0 here, that we have already discussed in previous examples, because of no staggering or no staggered joint in the particular connection, and that's why NS is 0, ASP becomes 0, divided by 1.25. Okay, then it comes out to be 45264 Newton, and that is 45.26 kilonewton. This is VDSB. Then in the second step, we have to calculate bearing strength of plate. Again, here VDPB is directly used. VDPB is equal to VNPB divided by gamma MB, or VNB, that becomes FUB upon gamma MB. Okay, so it is again 2.5 into KB into D into T, and that FUB upon gamma MB is for the calculation of VDPB directly. Assume P is equal to 3D and E is equal to 2D. Okay, these are the conditions we have used. In the previous example, we have used P is equal to 2.5D and E is equal to 2D same. You can use up to this maximum, P is equal to 3D or E is equal to 2D, and these are the assumptions according to IS code. K0 is the list of E upon 3D naught, P upon 3D naught minus 0.25, or FUB upon FY, and 1. These are the 4 conditions for the calculation of K0 in the formula, sorry, KB calculation. For KB calculation, these are the 4 conditions from which you have to calculate the value of KB, and we have to take list value of these 4 for the actual calculation. Okay, keep in mind here E by 3D not, P by 3D not given. Okay, directly D is not given, D not means diameter of hole is there, and just calculate this value E, P, FUB, FY already known now here, and you can easily find out these 4 values, and by looking over these values you can easily find out the list number. Okay, and just take the list value of KB or K0. KB is equal to 0.60 is list value out of these 4 here. Okay, now directly calculate VDPB from the formula given above. All the values from the VDPB formula, that is 2.5 into KB into D into T into FUB upon gamma MB, is now known. put all the values in the formula and find out the value of VDPB, which comes out 126.72 kilonewton, and you can easily compare shear strength of bolt, design shear strength of bolt, and design bearing strength of plate. Take the list value of these two, and that will be our bolt value. Okay, bolt value is the list of VDSB and VDPB, that you can easily get the list value of these two. Now, once we get list value of these two, we can find out the number of bolts required. Now the number of bolts required is the factored shear strength, okay, which is directly given in the statement. Factored compressive load 175 kilonewton, okay, factored compressive load upon bolt value PU upon BV, okay, that is bolt value. Number of bolts required is equal to factored compressive load PU upon bolt value BV, that gives you a number of bolts required. Okay, always take a round figure here, because number of bolts will never be in some digits. Okay, that is common sense. Just took the higher number from the digits come. Okay, 3.86, it will become 4 numbers, or 3 point something, that you can take higher number, that is 4. Okay, for the safe calculation. Then minimum pitch 2.5D and edge distance 22 into 1.5. These are the minimum pitch and edge distance conditions again, and these are the simple connection details. Okay, this left side higher size plate is gusset plate, and the inner plate connected by using these 4 bolts in a single row with edge distance 33 and pitch, minimum pitch, that is center to center distance between these bolts along or parallel to the load is that 175 kilonewton load is now applied in the along with this dotted line, okay, or along the horizontal in this case, and therefore this 55 em is pitch. Okay, you can read the definition of pitch, edge distance, gauge distance, and you will get all the clarification about this diagram again. Okay, this is ISA given, which is connected to this gusset plate, which is having 20 mm thickness. Okay, I think 20 or 12 mm thickness, I think 12 mm gusset plate. Okay, and that 175 load is applied along with these bolts. Okay, so this is simple examples. You have to remember these main 2 formulas, VDSB, VDPB, and some conditions for KB, then formula for number of bolts required, minimum, maximum, conditions of pitch, edge distance. Okay, so this is all about third example from the design of bolted connections. We will discuss again one more example. Okay, so just by using these examples, you have to uh, make your own notes, and you have to solve the assignments which is already provided to you. Okay, solve the assignment questions. Very similar questions are given in the assignment for your practice, and all these questions were asked in the previous exams. Okay, just solve the all the examples from the assignment and these provided questions in the videos. Okay, that is sufficient to all. Okay, thank you.